about obtuse triangle. For that case, I'll use this triangle for my reference. Okay, this is my obtuse triangle. In this triangle, the base is easy. Okay, to find the base, we can indicate this side as our base. Okay, this length as our base. But in this case, the perpendicular height is our difficult task. For that, you have to extend this line. Okay, you should extend the base and you have to connect this with respect to your opposite vertex. What is the definition for perpendicular height? From base, okay, from base, okay, its opposite vertex. From its opposite vertex, when we draw a perpendicular line, that's gonna be our perpendicular height. Okay, from base, from base, its opposite vertex. So its opposite vertex, which is indicated here. From there, you have to draw a perpendicular line towards base. That's the definition for a perpendicular height. So in this case, the perpendicular height should be located outside the triangle. Okay, these are some construction lines. Okay, here we put a dotted line to extend the base. These are some construction lines. But while we are dealing with perpendicular height, only you have to deal with this perpendicular length, which is indicated by using a pink color one. Okay, this is gonna be your perpendicular height. Okay, you have to consider about this one only. In base also, don't consider about the construction lines. You have to consider about this length only. This length only. This is the way you have to concern about the area in obtuse cases. Okay, this is little different than the previous case. In acute cases, okay, in acute cases, perpendicular height is located inside the triangle. In right cases, perpendicular height is one side. Okay, one is base, one is perpendicular height. But in obtuse cases, the perpendicular height should be located outside the triangle. Okay, here inside, here one side, here outside. Okay, these are the things you should know about an obtuse triangle. Then let's do an example. For that, I'll use another triangle. Okay, here this is my triangle. The base is indicated as 23 meters, and to indicate your perpendicular height, let's use some construction line and towards here we have to do another construction line to our perpendicular height. Okay, this is your perpendicular height, which is indicated as 12 meters. Okay, 12 meters. The equation is same. So to find the area, we have to identify our base and perpendicular height correctly. Okay, in proper manner. Then let's substitute those values in the formula. Half into base into perpendicular height. So half is here the base, which is indicated by this one. Okay, this is going to be our base. So 23 should be multiplied by the perpendicular height is 12. Okay, 12. Then let's multiply 23 times 12. It will become 276 divided by 2. 276 divided by 2 will give you the answer as 138 square meters. Okay? So your answer should be 138 square meters for this obtuse triangle. But the thing, the perpendicular height should be located outside the respective triangle. When we think about the first case, half into, we just need base and perpendicular height only. Just leave the additional 8. Okay, don't consider about that one. We have to substitute base as 5 and perpendicular height as 2. Then it will become 10 upon 2. Finally, our answer for area 5 square centimeters. That's all for this question. For the second one, half into the base is 36 and the perpendicular height should be 17. Okay, so half into 36 into 17. So that will give you 18 times 17. 612 divided by 2, that will give you 306 millimeters. This should be your answer. Okay. For the next one, the base should be 20 and perpendicular height is 7. So half into 20 into 7. So 140 divided by 2, that will give you 70 centimeter. That's the area of this particular obtuse triangle. Okay, this is the way you have to do all these questions.